Okay, so piecewise functions, I know that you have seen them before. At this point, with the last couple of years how they were, I'm not sure if you've actually graphed them and done other things with them, but I know you've at least seen them in here. Maybe you didn't even know what they were called, and that's totally fine. So let's start off with the definition of what piecewise functions are. They are functions defined by two or more sub-functions, each with their own domain. Okay, so they are functions defined by two or more sub-functions, each with their own domain. So here's what this means. We're going to look at evaluating them first. First of all, this says f of x, and then there's this weird looking thing. This is supposed to be one of these. I don't know why it printed all weird. So there's not like that some weird symbol or something you have to know. It's just like one of those big squiggly brackets. So instead of f of x just being this part, or something like it like we're used to, f of x consists of, so this is my big function, these are my sub-functions, and they each have their own domain. So this is telling me that I have an absolute value function, this specific one, everywhere where x is less than -3. I have a quadratic somewhere between -3 and 7. And I have a square root function when x is greater than 7. So I have like little slices of these things that are put together. Okay, does that make sense? Which means if all I had, again, was this, and I had to evaluate f of -5, I would just substitute -5 in, substitute 2 in, substitute 7 in. But I have to pay attention to the domain here and make sure I'm looking at the right pieces. So when I look at the -5, I have to figure out which domain it falls into. Which one does it fall into? First, second, or third? Third. The first one. First one. -5 is less than -3, right? Okay. So it falls into this one. So that means I don't substitute it into all of them. The only one that makes sense is for me to substitute it into here, because this is when x is less than -3. So this is going to give me 2 times the absolute value of -5 minus 5. And then -5 minus 5 is -10. Absolute value is 10 times 2 is 20. What are you confused about, sweetheart? Where'd I lose you? Well, you have to find where they work, and then you actually substitute it in. Like, I need to evaluate f of -5, but I don't substitute it into all three of them. I only substitute it into the one that makes sense. Does that help? Kind of? Okay. So then we'll look at f of 2, the middle one. Good job. 2 is between -3 and 7. So I had to identify which one it works in. Then I have to actually substitute it in. So this is going to give me -2 squared plus 4 times 2. And let me just remind you that -x squared and -x squared are two completely different things, right? I'm not squaring -2, I'm squaring 2 and making it negative. So that makes this -4 plus 8, so f of 2 is 4. Everybody good with that? All right. F of 7, where does 7 fit in? The last one, because it's included on this one and not on that one, so I'm substituting that one in here. This is going to be equal to the square root of 2 times 7 plus 6. That's the square root of 20. I do not type it into the calculator. I do not leave it like that. I have to simplify my square root. What does the square root of 20 simplify to? 2 squared 5. Good. So f of 7 equals 2 square roots of 5. There you go. Okay. What questions do we have? We all good? All right. Let's go ahead and try this next one. Again, let me fix this. All these brackets, like something weird happened to them. I don't know why. All right. G of -3. Where does negative 3 fit? First, second, or third? Second. Negative 3 is between negative 4 and negative 2, right? So if it's in here. So that means the value is 8. So it's just 8. There's no work to be done there. Then g of negative 8, where does negative 8 fit? First, second, or third? The first one. So this gives me 1/2 times negative 8 cubed plus 7. Okay, so once again, no calculator. Let's think smarter, not harder. First of all, when I cube negative 8, is it going to be positive or negative? Negative. And so I'm going to say, I know when I do 1/2 times all this, it'll be some negative number, and then I'm going to have a plus 7. Right? So now I don't have to worry about my sign. I know whatever I get, it's going to be negative. Now, so that what that means is I would have 8 times 8 times 8, and I have 1/2 of it, right? So what I could do is 8 times 8 times 8 and then take half of it, but yuck. Instead, think about doing it like this. Half of 8 is 4. 8 times 8 is 64. Then anytime you multiply something by 4, it's easy. You double it and then double it again. So 64 times 2 is 128. So then I have to do 2 times 128. Well, 2 times 100 is 200. 2 times 20 is 40. 2 times 8 is 16. So I get negative 256. Learn how to manipulate the numbers in an efficient way for yourself. But you don't get good at that stuff unless you practice it. Okay? And then that will give me g of negative 8 equals negative 249. Any questions? All right, you do that last one. Just 0.9, right? All right, there we go. What questions do you have? All right, so let's look at graphing them. Once again, stupid little symbol. I have 2 parent functions that I have to deal with here. So one of the things that a lot of you were not doing yesterday when you were graphing was sketching your little tiny parent functions, like I said. And that's one reason why you had no idea where to go from there. So I have 2 parent functions that I have to deal with. I have an absolute value, and I have a linear. My absolute value has 3 anchor points. My linear has 3 also, but chances are pretty good with the lines. You won't have to worry about anchor points because you can use your other line graphing skills and it'll work just fine. But what you have to remember is you're not graphing both of these like right on top of each other. You're only graphing parts of each one, and you have to figure out which part of it that you need. So we're going to start with the absolute value. I have an absolute value function everywhere x is less than 0. So what I need to do is substitute this 0 in so I can figure out what my right boundary is. I know it'll be, I can go up to there and then everything less than that. So when I substitute 0 in here, that'll give me 3 minus 1, which is 2. So I'm going to go to 0, 2. This is less than, so it is an open circle. Okay? I can't go to the right of that open circle with my absolute value because it says I only get that when x is less than 0. Then I go about graphing my function. I'm going to start with this point right here. That anchor point is negative 1, 1. So I go to negative 1, 1 and put my pencil down. Then I'm going to have to go to the left 3, 1, 2, 3, and go down 1. There's a point. Then I'm going to use 0, 0. And I'm going to go to the left 3 and down 1. Then I'm going to use 1, 1. and I'm going to go to the left 3 and down 1. And I have all 3 of my anchor points actually fit on there. Sometimes they won't. Okay? I know what I'm supposed to be drawing is supposed to be an absolute value, so then when you do that, you want to be real careful. It's everything less than 0. So this is fine right here, but then when I go here, I can't draw it out here like this. That doesn't make any sense. I have to stop here, and I can't even fill in my circle. And that is the first section of my graph. What questions do you have? Okay, so then the second section is the line. I substitute in the 0 to see what because it's going to be everything greater than 0. So I need to see what my left-hand boundary is. When I substitute 0 in, I'm going to get -5. So I go to 0, -5, and that's a closed circle because of the domain. Then from there, I don't really care about my anchor points because I know how to graph a line. That's in y equals mx plus b. Even if it wasn't, I have a point, and I know what the slope is. It's 2. So from here, I can just go up 2 over 1. That's another point, and there's my line, or the part of my line. What questions do you have? Do you understand how I came up with all that stuff? All right, so my domain. I start out here at -infinity. I go until, well, x equals 0 is not a point on this section, but it is a point on this section. So then I can keep going. So it's actually from -infinity to infinity. My function is not continuous, but my domain is. Then my range. Do I start at -infinity? No. I start at -5. And I include that because it's included. And then I go to infinity. Do I have any discontinuities? Yes. I have a what kind? Jump. So it is a jump discontinuity at x equals 0. X equals 0. It's not an ordered pair. That's not how you talk about discontinuities. You talk about them at their x values. Okay? What questions do you have at this point? Are we good? All right, let's look at the next one. All right, so here I have 2 subfunctions. I'm going to draw my little parent function for both of them. Okay, and so that gives me, I have a linear and I have a quadratic. So again, with the linear, we probably won't care about the anchor points, but for the quadratic, we definitely will. Quadratics are pretty simple, but they do have 5 anchor points to help us with the shape of things. So in my first one, it's everything where x is less than -3, so I need to take this -3 and substitute it in. So -4 minus a -3 is what? -1. So I'm going to go to -3, -1, and that is a closed circle. So then I have to draw in, again, it's a line. What's the slope of the line? -1, okay? So I can just count my slope, and you should know since it's negative that the slope goes that way, right? So that means I need to go to the left 1 and up 1. There's my point, and there's my graph right there. Then I substitute in -3 here. -3 squared is a +9 times a -1/2 is -9/2. So that's like -4.5 when I graph it. So I'm going to go to -3, -4.5. 1, 2, 3, 4.5. And that is an open circle. Then I plot my anchor points. Or I don't plot my anchor points. I transform my anchor points. All I'm going to do, have 2 things going on here. I'm going to reflect in which axis? X, and then I have a vertical compression of 1/2. So I'm going to start over here at -2, 4. So I'm going to start at -2, 4. I'm going to reflect in the x-axis, so I end up down here, then a vertical compression of 1/2, end up right there. So I did that one. My next anchor point is -1, 1. I reflect in the x-axis, vertical compression of 1/2. Now I got to do 0, 0. 0, 0, reflection, compression does nothing at 0, 0. It's still at 0, 0. So I have my first 3 anchor points. The last 2 I can just get from symmetry. I have one there, and I have one there. Then when I go to draw it in, I got to pay attention to my boundaries so I don't go too far. It's going to come and look like this. Okay. What questions do you have? All right. So my domain, I know I start at -infinity. Is it continuous to infinity? Yes, it is. Where does my range start? -infinity. Is it continuous to infinity? Yes, it is. Do I have any discontinuities? Yes. I have another jump discontinuity at x equals -3. Not always. I think all of our examples end up being jump, but there are other ones we could have holes and things for sure. The one we're going to skip would be something different, but we need to skip it because we haven't done these yet. Okay, we good so far? All right, so let's look at number 6. All right, so I got 3 things going on here, plus an extra crazy stupid bracket. So I got 3 parent functions I need to think about. I've got a linear. The second one's linear, but it's horizontal. And then a quadratic. So the only one I most likely care about anchor points on are the quadratic. All right, so I'm going to start by taking this -4 and substituting it in here. Because it's everything where x is less than -4, I'm going to have less than or equal to, I'm going to have that. So -4 times 3 is -12 plus 8 is -4. So I'm going to go to -4, -4, and that is a closed circle. My slope is 3. It's positive, which means it's tilted this way, right? But from here, I can't go up 3 and over 1 because I can't go to the right of it, right? So instead, I'm going to have to go down 3 and to the left 1, so I'm still tilting the right way and can get that part of the line in. So be careful with that. Make sure you're thinking about those boundaries there. Okay, everybody good so far? All right, so then my next piece starts at -4. So when x is -4, y is 1. I'm sorry, -1. And this is open. And then when x is 2, y is still -1, and that is closed. And then it's just -1 the whole time. It's a constant function, so I can just connect those. And I'm good. Okay, we good? All right, so then I have to substitute 2 in here to get my other endpoint, or my little end open circle, whatever it is. So 2 minus 2 is 0, squared minus 5, so it's -5. So I'm going to go to 2, -5, and that is an open circle. So then I have to start doing my thing for my quadratic. My transformations, I'm going to go to the right 2 and down 5. We agree with that? So I'm going to start here at -2, 4. -2, 4. And then I'm going to go to the right 2 and down 5. Can I put that point on the graph? No, because it's not in the domain I want. So that anchor point ain't going to be there. Then I use -1, 1. I go to the right 2, down 5. I still am not good, right? Can't use that one. So I use 0, 0. Go to the right 2 and down 5. Well, that's where my open circle is. Don't make it a closed circle now. It's an open circle. So at least I know I'm going to have something on there. Then I can do 1, 1. Go to the right 2 and down 5. And then 2, 4. Right 2, down 5. So instead of those just being 2 random points, you know exactly where they came from this, and you know that all you're going to have is this part of the graph right there, right? So that means my picture looks like this. Everybody good so far? All right, so my domain, where do I start? Negative infinity. Is it continuous all the way to infinity? Yes. My range, where do I start? Negative infinity. Is it continuous all the way to infinity? Yes, it is. How many discontinuities do I have? 2, and they're both jump. And it's still at the x, but this time it's a set of numbers, so I'm at negative 4. Is that right? Negative 4 into 2? It should be a set. Like, learn to put things in sets, yeah. Everybody good so far? We good? Okay. So let's start this one together, and then I'll have you do the middle part. Alrighty. So I have 3 little subfunctions again. I have a horizontal line, I have a cubic, and I have a square root. So I'm not so worried about the line, but my cubic, I have 5 anchor points. My square root, I have 3 anchor points. Okay. So let's start with this first section. Everything, when x is less than negative 1, y is going to be 7 the whole time. So when I go to negative 1, 7, 2, 4, 6, 7, that is an open circle. And then it's 7 all the way that way. Okay. All right, now I want you to get the cubic part on there. Do your 2 endpoints of the domain first, then try and do your anchor points. Give you a few minutes to get that going. Okay, looks like most of you are on the right track, so I'm going to start talking you through it. So if I substitute in this negative 1 cubed is negative 1 minus 1 is negative 2. So I'm going to go to negative 1, negative 2, that is a closed circle. I'm going to substitute in 2. 2 cubed is 8 minus 1 is 7. So I'm going to go to 2, 2, 4, 6, 7. And those are both closed circles. I can't go any farther to the left of negative 1 or any farther to the right of positive 2. So I start looking at my anchor points. Well, if I do this negative 2, negative 8, and all I'm doing is going down, then that's not going to work for me. So that one doesn't work. Then I have negative 1, and I shift down 1. Well, that is that endpoint, so that's good. 0, 0, shift down 1, I'm here. 1, 1, shift down 1, I'm here. I didn't mean to accidentally go off to another point. Then 2, 8 would be here. I shift down 1. That's my other endpoint. So remember, this is just like a little slice of that. I know exactly which pieces I have, so I can just come in and make it like so. What questions do you have? We good? Joelle asked me a question. I can tell by the look on your face. Something. There's something. Say it. You liar. What's your question? Where'd I lose you? From the beginning of everything today, or from... You have those 3 points. Or did you do those because I did those? Yeah. I was like, I don't know where you got that point, and you're not the only one that's been getting that point. He got it too. Oh, it's because y'all are doing a... What the heck is that? Does that look like a cubic?
Oh.
I think you used the wrong points, but this was right. You just take all you're doing is doing your anchor points just like we did yesterday after you get your end points on there. Does that help? I don't know what you're confused on. Okay. All right. So then we got the square roots. Well, the first thing I'm going to do is substitute in this 2. So 2 times 2 is 4. Square root of 4 is 2. That's negative 2 plus 1 is negative 1. So I go to 2, negative 1, and... Oh, wait, I'm sorry. 2, wait a minute. Yeah, that's right. 2, negative 1. Sorry, I was second guessing myself there. 2, negative 1. And that's an open circle. Okay? Then I got this 0, 0. So my transformations here are a reflection in x, horizontal compression by 1/2, and go up 1. Right? So if I start here at 0, 0, the reflection does nothing, the compression does nothing, I go up 1. Do I get to plot that point? No. My next point is 1, 1. I'm here. I reflected in the x-axis, horizontal compression by 1/2, up 1. Don't get to do that one either. This point right here is 4, 2. Okay, I can reflect that in the x-axis, horizontal compression by 1/2, up 1. Well, that is that point, and I'm out of anchor points. Okay, sometimes that happens. I still need to plot something else. I don't get to just like draw something random there. So if this is 0, 0, 1, 1, 4, 2, what would the next pretty point make sense to be? 9, 3. Okay, so let's go to, so this only goes to 8, but let's go to 9, 3, right? I do a reflection in the x-axis, I end up down here. I do a horizontal compression of 1/2, that puts me at 4.5, and then I go up 1, so there's a point. If you wanted another one, what would the next pretty point be? 16.4. Okay, so let's say we're out here at 16.4. I reflect, so I'm down here. A horizontal compression of 1/2, so now I'm at 8, and then I can go up 1, and that gives me just another point to get my curve in. You wouldn't have to do that one necessarily, but you need at least one other one. Okay, we good? But you see how you can come up with your own anchor points, the ones that make sense for the parent function? It's not a matter of memorization, really. All right, does my domain start at negative infinity? Yes, it does. And then, does it go continuously to infinity? Yes, it does. My range, where do I start? Negative infinity. Do I go continuously to infinity? It stops at 7. So it is continuous, but it doesn't go all the way to infinity. It stops at 7. Do I include it? Yes. And here, once again, these all end up being jumped, but yes, there are other kinds of discontinuities. At x equals negative 1 and 2. Okay. What questions do you have? Okay. If you're watching the video, there's going to be a separate video that explains the delta math, so that in case you get confused on any of it, so you want to make sure and watch that.